Hello everyone, welcome to the first chapter of the Huawei HCIP OpenEULER course. This section, we will continue to introduce the common service management of OpenEULER. We have introduced the Apache and Nginx web service. Next, we will introduce the other web-related service. The first is DNS, Domain Name Resolution.
In the previous Nginx practice, we configured local static domain name resolution. Next, we try to replace the original static DNS with a DNS server. First, we prepare an OpenEULER server and install the DNS software in binary mode by running yum bind command. After the bind service is installed, we can run the system control start named command to start the DNS service. Then we can check the port listening status to check whether the service is normal. We know that the DNS port is 53, so we check whether the service is normal. Here the port 53 is normally listened, so it means the DNS is installed and started successfully. We can use rpm-ql bind to view the key configuration file for the DNS service. And here, first one, log rotate.d named. This is log rotation file. Name D, mean configuration of configuration file. Name d.conf, main configuration file. Define the domain as being named binary command. And check conf, check in the configuration file. Log file named .log. And the main directory of data files named D. Root domain server named .ca. Template of the forward parse long file. Template of reverse resolution long file. And the default path for downloading files from the DNS server. And these are the configuration files for the DNS service. In addition, there are several common configuration commands. For example, named checkconf command is used to check whether the DNS configuration has syntax errors. And if we want to check whether the configuration of the DNS data file is incorrect, add the domain name and the corresponding data file to the end of named checkdown. And we can run the rndc reload command to reload the DNS configuration. Besides this, there are three common DNS service check tools. One is NSLookup, which is used to check whether domain name resolution is normal or can be used to diagnose network problems when a network fault occurs. And there are two ways to use it. The first one is interactive, which is used for multiple queries and diagnosis, such as NSLookup input 3w.test.com to return the parsed IP address. Enter the IP address again. Return again. Or the second way, non-interactively, directly specifying the domain name for a single query and diagnosis. For example, NSLOOKUP 3w.test.com, directly view the result. And another tool that is more powerful than NSLOOKUP is Dig, which supports more DNS query functions, such as DNS tracking. And also, if you add trace, it's used to trace the parsing process. The third one is host. The function is similar to NSLOOKUP, but the output is simpler. Next, let's complete the resolution on a new DNS server and statically resolve the Nginx 3w.test.com to the internal IP address of the Nginx configuration server. In this way, the Nginx server can complete domain name resolution through the DNS server, and no need to configure the local etc host file anymore. So first, we need to create a forward loopback resources record. Bind provides the administrator with the template file for configuring resource records. The file is stored in var named directory. And the named localhost template for forward loopback is named localhost. We can run the cp command to copy the file as test.com.done. The option P ensures that the target file or directory retains the same permission setting and timestamps as the source file or directory. This way to protect the file permissions and the timestamps during the replication process. Then we edit the test.com.done file and modify the configuration. Here the TTL1D indicates that the TTL is 1 day that a DNS record can be stored in the DNS cache. Here is the SOA record, which defines the test.com domain. .master.test.com is the name of the primary DNS server, and admin.test.com is the email address of the administrator. NSMaster is the new server record, indicating that the master is the name server of the test.com domain. It's going to be written down below master A. 192.168 and 0.172 columns master is the name of DNS server, which is an A address record. The following IP address indicates the private IP address of the current DNS server. Then there is a same name with 3W as an alias, point to main as a real name, indicating that the alias of 3w.test.com is main.test.com. A records is created for main A, indicating that the IP address pointed to by main.test.com is private IP address of Nginx. We check the IP address and then we save the settings. Next, we modify the main configuration file. We change the IP address After listen on port 53 to localhost, because the DNS-zone file states that the master address is the private IP address of the localhost. Here we change the IP address to localhost to avoid service running problems caused by IP address mismatch. Allow query, we need to change localhost value to any, because we need to access the DNS from the Nginx server. Then we add a following line, check -names, master check the domain name of the master server. If the domain name is different, warn. Avoid service running problems due to domain name setting. We save and continue. We need to modify this file. We add a new configuration about test.com DOM. The configuration format is the same. Type master file test.com.dom. Save configuration and we run named -checkconf to check whether the configuration of DNS configuration file is correct. We use check-done to check configuration test.com, and the file path is var named test.com.dom. If OK, the configuration is correct. Then we run the rmdc reload command to reload DNS service configuration. The command output shows that. We switch to the Nginx server vhost. Use nmcli connection show to obtain the network connection name. We need to change the IP version for DNS server IP address of the NIC. The address is the private IP address of the created DNS server. Then we use connection down and connection up to make the configuration take effect. After the configuration is complete, we run the nslookup command 3wtest.com. You can see that the parsing is normal and has been resolved to the IP address 2.216 to the Nginx server. The alias is 3w.test.com, officially called main.test.com. And it's finished the 3w.test.com domain name to IP address forwarded resolution of the address. Next, we create the configuration to implement reverse resolution of IP address to domain names. We're back to the DNS server. The template file of the reserve resolution resources record is stored in var named directory name.loopback. We use the cp command to copy the file. And what we need to be done here is reserve resolution 192.168.2.216 as 3w.test.com. So with cp named loopback and to.dom, and then -p to keep file information and timestamp. We change the name of to.dom file, master, and email address. Here, master.test.com. Admin test.com is email address. NS master primary DNS server and master A. Is the internet IP address of the DNS server. And we check the IP address and copy it to the DNS server. This is the forward resolution. The PTR reverse resolution is the resolution to the 3w.test.com. The address is the same, 2.1216, and the zone is 2.done. So here we can write 216 directly, which means that the 2.216 is parsed into 3w.test.com. So we save, and then we need to modify the file and add the reserve resolution configuration. Zone 2.168.192.in address.arpa. It is the same as the above format, but it's written backwards here. Type is master. File, that is 2.done. Allow update. Okay, save the configuration. We run the named checkconf command to check whether the DNS configuration file is correct. We run check done. and the then is 2.169.192.done. To check whether the configuration file is correct. Here the error message shows that the earliest SOA record file is indirect. So we need to modify. Here the master.test.com is configured and at cannot be used here. We checked it again. Domain check is fine. Reload the DNS service. Switch to the Nginx server and we run ns lookup. Reserve resolution 2.216 to view the reverse resolution. The 216.2.168.192 parse name 3w.test.com. So it indicates that the resolution is successful. So far, we have learned about the configuration of the DNS service.
This section will describe the DNS resolution process, resource record types, and standards. The DNS server is set up so that Nginx can access domain name through the configured DNS server. In addition, the reverse resolution function is tested. That's all for the introduction of DNS. If you are interested in, you can operate yourself after the class. Thank you for watching.